Hi everyone, welcome back. Today we are going to talk about using proportional parts with parallel lines. First, we are going to talk about the triangle proportionality theorem. A corollary of this, that means something that comes from the triangle proportionality theorem. It says that if three or more parallel lines intersect two transversals, then they cut off the transversals proportionally. So, for example, if we know that these three lines, AE, BF, and CG are all parallel, and we have these transversals, then we know that this section AB over this section BC, so those are both coming from this transversal on the left, is going to be the same proportion as how we cut the other transversal. So E to F is going to be the same, E to F over FG is going to be the same ratio as how the other transversal was cut. Let's use this in an example. It says Megan is drawing a hallway in 1-point perspective. She uses the guidelines shown to draw two windows on the left wall. If segments AD, BC, WZ, and XY are all parallel, those are these vertical lines, AB equals 8 centimeters, DC equals 9 centimeters, ZY equals 5 centimeters, find WX. So we're going to look at one transversal at a time. So let's look at this top transversal. I know that 8 over WX will have to be the same proportion as 9 over 5. Notice that I took this in the numerator, 8, from this first window on the left. That means I needed to put 9 in the numerator as well. Now, hopefully you guys are really used to this by now, solving these ratios. We cross multiply and divide. 8 times 5 gives me 40, and then 40 divided by 9. I'll have to round, it's not perfect, but I get 4.4. I want you to pause the video and try the practice problem below. Here's the correct answer for that. Now let's look at another one. If we have two transversals and one of the transversals is cut into congruent parts, then it means any other transversals also cut into congruent parts. So since we know that these lines are all parallel again, and we have this transversal cut into congruent parts, it means this is also congruent. So we know EF is the same as FG. Let's use this in an example. It shows us that MP is congruent to segment PQ, and notice that's one transversal. So that means any other transversal that goes through these three parallel lines will also be cut into congruent pieces. So I know JK must be congruent to segment KL. Therefore, 6x minus 5 has to be equal to 4x plus 3. And I can solve this. So let's see. Subtract 4x on both sides, that gives me 2x. Add 5 on both sides, that gives me 8. Divide both sides by 2, you get x equals 4. Now, even from, if you didn't know that corollary, you could still find y because it's already marked on your picture that those two segments are congruent. So even without learning what I just taught you, you should already know that congruent segments have the same measure. All right, add 7 on both sides, subtract 3y on both sides. This one gives us a decimal. 7.5 is equal to y. All right, pause the video. There are 2 practice problems for this one. Here's the correct answer for A and B. And finally, here's what I want you to reflect on today. I want you to write the converse of this statement. If 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Write the converse and then tell me, is it true or false? That's all for today. Tomorrow we will be learning more about special segments within triangles. So remember, we've already learned altitudes. We have learned angle bisectors, medians. If you need a refresher on any of those, go back and look in your notes tonight. We'll be learning a lot about them tomorrow. See you then.